the chat box so that I get to know that you guys can see me. Okay. Hi everyone. Hello everyone. How are you all? Good morning, good morning, good morning everyone. Very, very, very good morning. Let me just complete my setup here so that I can read your chat. Okay. So guys, how are you all? Good morning. Welcome back to Vedantu's JEE channel. How are you all? I'm good, I'm good. And it's the start and the beginning of the week. I have been reading a lot of memes which says that there are no weekdays now. There are no weekends now. Every day is a day. We are living in yesterday, today, and tomorrow. Yes or no? How many of you have lost the track of time? I'm good, guys. I'm good. How are you all? Namaste, namaste, Raghu. After this lockdown, I need to get my eye checkup done for sure. Okay. I can read Shankha, Dev Chauhan, Meera, Rahul, Atharva. Awesome, awesome. People are here. Okay, guys, I'm good. I'm good. I'm good. Dev, I'm good. Okay, awesome. So, guys, yet we are back again. So, this is a new series that all of you are witnessing, and I think that you guys are enjoying this as well. This is basically doubt destroying session for physics, chemistry, and maths. This is our next session on physics for work, energy, and power. And for all of you who are here for the first time, this is me, your Suri Sir, okay, also known as Mogambo. Why do I call myself that? Is because when you will crack the examination of JEE, Mogambo khush hoga. Yes, okay. This session is about the doubts that you guys have asked on the community page. You must have seen that there is a link which was shared for asking the doubts. It was a Google form. Okay. So अगर वो अभी भी नहीं पता है, so do subscribe to the channel so that you are not missing out on any of these forms which are shared over there. Okay. इस बात को मैं हिंदी में भी समझा देता हूँ. डाउट्स कैसे पूछ सकते हो? जो कम्युनिटी पेज है यूट्यूब चैनल का, जो जेई वेदांतु यूट्यूब चैनल है, उसमें बहुत सारे टैब्स हमें दिखाई देते हैं. देयर इज अ टैब जहाँ पे लिखा हुआ है कम्युनिटी. उस कम्युनिटी पेज पे कंटिन्यूसली यू विल गेट टू नो द लाइव and other informations related to the live sessions. Okay, so whenever we are posting about any session which is going to happen with respect to this doubt solving series, then there is a form link which is shared over there. उस लिंक पे क्लिक करके you will be directed to a Google form. There you can post your doubt along with your name and your details. So that's how you can get your doubt solved. Okay, so when it comes to work, power, energy, I have picked up majority of the questions which are there. Few things that I want to tell you people. If your name doesn't come here, that does not mean your doubt is not getting answered. Because I have seen there are so many common doubts in a chapter. So maybe we have picked a few questions, but your answer is getting being delivered. Okay, so don't think कि तुम्हारा नाम नहीं आया so तुम्हारा doubt नहीं लिया. Okay, remember what doubt you asked. If you have asked about work energy theorem and someone else and many people have asked about work energy theorem, we are not mentioning, we might not have mentioned all of their names, but your doubt about work energy theorem will get clarified here. Okay, cool. So guys, we'll go forward. In some time, I'll get into the doubt solving discussion, and there are important information for people who are here for the first time that I need to share first. First thing first, right now, as the entire country along with the entire world is going through a very difficult time, we don't want you people to take a risk with respect to your health. Do not go out, stay at your home. Your studies are being taken care of, so you don't have to worry about it. घर पे बैठना है और अपनी पढ़ाई को continue करना है. Your studies will keep on going. You can spread the word. Don't spread the infection. Spread the word. Tell your friends. Your friends of friends should know that at Vedantu you can get your studies going for any standard, for any examination that you're preparing for. Okay, so do tell it to your friends. Okay, And yes, thanks to that, uh, Vedantu's app has now crossed 5 million user downloads, or you can say 50 lakh downloads. Okay. Yep. So अगर अभी भी सब्सक्राइब नहीं किया है चैनल को, so do subscribe guys. You see that option over there. There is a like button, there is a subscribe button and share, so you can subscribe to the channel as well. Okay, and press that bell icon so that you are not missing out on any information which is with respect to the notification of this channel. Okay, apart from that guys, if you are preparing for JEE, you know that JEE examination has got postponed at least till May end, so you have still a lot of time left with you. You can come for the crash course with us as well, where 90 live sessions and 20 comprehensive tests along with doubt solving and replay recording possibilities are there for you. This session or this course has started on 9th of April. You can still join and you can continue your preparation. How you can join? By following this link, which is also available in the description of this video. Use this coupon code SMCC. The course, which is worth rupees 30,000, will be yours for just rupees 5,999. Okay, Siddharth, sorry, I will try to keep the session in English so that it is understandable to everybody. Okay, I come from the northern part of the country, but we are all able to understand English, I guess. Okay, especially physics wala English is something which is understandable. Okay, cool guys, here it comes, the very first question for all of you. This is question which is asked by Krishan Kant from Moradabad, UP. So Krishna is asking, can you explain the term energy? I mean, give a feel. Because I have read the definition, but that doesn't make me feel of what energy really is. Love you for Vedantu team. Okay, thank you so much for asking this question, Krishan. Well, guys, it's a very, 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 I would say preliminary, but a very fundamental and a very good question according to me. Because this is how I actually love to explain as well as understand physics as. That you being able to create a mental image of anything that you are studying in this subject. So I would rather start by saying that energy is the most important quantity of this entire subject physics and for this universe as well. So when we study physics, energy I say is the most important quantity even before force. More fundamental and more important. Why? You can get the importance of energy by this, that all the units that you study. Which units you guys study? You guys study mechanics, you guys study thermodynamics, electrodynamics, optics and modern physics. So all the classical physics division which you study, mechanics, electrodynamics, thermodynamics and optics, they are divided on the basis of the energy that is involved over there. If you are studying mechanics, the working energy in the background is mechanical form of energy. That's why it is called mechanics. Kinetic and potential energy are there in the background. That's why the name of the unit mechanics. When you are studying thermodynamics, the name of the energy which is working in the background, you are aware about it, is heat. When you are working about a problem in electrodynamics, the energy which is there in the background is the electrical form of energy or the potential energy of the charge. Okay, and lastly, optics, the energy which is working in the background is light. Okay, yep, I hope the importance is clear. But now coming to the feel part of it, that how exactly do I understand that what exactly energy is. So for that, the explanation is going to be a little philosophical. Understanding energy in a given situation, in a given problem in physics, is just like understanding it as the soul of a body. हिंदी में समझाऊं तो the way our body has a soul, हमारी body में एक आत्मा है, बिल्कुल वैसे ही energy is basically the soul of any situation. Like if you are talking about a moving car, the soul of that moving car is basically the kinetic energy. If you are talking about the ceiling fan which is there, which is revolving, it also has kinetic energy, but the rotational kinetic energy. If I speak about the current which is flowing in your wires for any device to be working, that's the electrical energy, which is the soul of that particular device. I hope you are getting it, right? Bookish definition, certainly. I know that this guy has mentioned that he has read the bookish definition already. It's the ability to do the work. But how to get the feel of energy, this is how I would rather understand it. Okay. Next one. Sir, I find this topic difficult. Please give some important points to prepare this topic. And sir, please open your new Vedantu Physics channel on YouTube so that we can get all physics stuff here. Okay, so about the second part of it, I do not know how, when and how Vedantu Physics channel is going to come. No comments on that. Okay, the name of the student is Jayesh Bankar from Kopargaon. Okay, I'll certainly try to help you with the first part. That is, which all topics should you focus on this particular chapter? Okay, I'm having a difficult time in tracing my own cursor. Okay, so guys, this chapter, as the name suggests, chapter is about work, energy, and power. The name of the chapter is always the summary of the chapter, by the way. Okay, when you study work, in work you will study work done by constant force. You can study work done by a variable force. I'm giving you a summary, okay, or you can say the bird's eye view. So work done by constant force, work done by variable force. When you study energy, energy will be of two type again. One is kinetic energy, other is potential energy. But when you are studying potential energy, again you will have two types of energy that you will study. The two types of forces which will result in possibility of potential energy. One of the force is called conservative. I will come to the explanation of that because somebody has asked this question as well later on. So there are conservative forces, and then there are non-conservative forces. Okay. Then comes your power, which is basically the ability to do the work, or to the amount of, ability to do the work was energy. Power is basically the amount of energy transferred per unit time or amount of work done per unit time. So you can write the amount of work divided by time or amount of energy transferred per unit time. That's how you divide the power. So this is basically the overall bird's eye view of this chapter, Jayesh. Okay, I hope it gives you an idea how to study this. We'll come to the part that what is conservative and non-conservative forces in a while. Okay, moving on. The unit of force and length are made 3 times of their earlier value. Okay, so the earlier system, the energy is 81 joules. What will be the energy of the same system in the new units? This is the question asked by Sanghishta Ghosh from Kolkata. Okay, Sanghishta. So this is basically a question from work, not from work energy power. This is a question from units and dimensions. Very fundamental chapter, by the way. So what does it say? First of all, when we write 81 joules, this is equivalent of writing it as 81 Newton into meter. Joules is not Newton meter, giving you this very clearly an information about Newton meter is the unit of torque, but dimensionally, what is joules is what is Newton meter. So that's why. And why am I doing this is because the question has force and length given in it. So work and energy have the same, units and dimensions. That's why. So now 81 Newton meter is basically what I'm going to work with. So we know that the value of a quantity in a unit system N1 U1 should be equal to the same value in some other unit, that is N2 U2. So whatever is 81 Newton meter, okay, that value will remain same in any other unit system. So if I'm changing the units of Newton meter, then you see what will happen. 81 Newton meter, what has happened to this? The numerical value in the new unit system is something that we do not know. Let's call it X. That's what we have to find out. But the Newton, that means the force unit, becomes 3 times. So that means Newton becomes 3 times of N dash. The Newton unit has changed to 3 times the original unit, and the unit of length has also become 3 times. So this becomes 3 m dash. Okay guys, so what do I get here? I get the value of X N dash m dash, which is X Newton dash meter dash. Newton dash meter dash is basically the new unit, by the way. So that is what has happened. This is 81 divided by 3 into 3, that is 9. So the value that we are getting for x, when you simplify this, comes out to be 9. So in the new units, the value of the same quantity will come out to be 9. Okay. Okay. So as I can see, people are trying to understand how to ask this doubt. I'm repeating again because people have just now joined the session. So for people who have just now joined the session, if you want to ask the doubts for a particular chapter on the YouTube channel of Vedantu JEE, first of all, do subscribe that channel so that you get to know about the information and notification. Hit that bell icon also. On the community page, you will always find the information regarding these doubt solving sessions. We float a Google form there where we mention the name of the chapter from which you can ask the doubts, and then the students who are coming there, they are directed to a Google form where you enter your doubts. Okay. Now, next question. As I told you earlier also that the question of explanation of conservative and non-conservative force will come. So the broad classification has been given here. Gautam from Trivandrum has asked this question. Sir, can you please explain about conservative and non-conservative forces and explain what exactly F equal to minus du by dx mean? Okay. So you can see what exactly the difference between conservative and non-conservative force is. The most important understanding of conservative and non-conservative force I want to give you people is this. Conservative forces are the one which will never try to change the mechanical energy of the system. What is mechanical energy? Kinetic plus potential. They will only try to convert kinetic energy into potential energy or potential energy into kinetic energy. They will only try to interchange these two energies to each other, but will keep the total sum of potential plus kinetic energy always constant. Remember that. But when it comes to a non-conservative force, it will try to change this total sum of mechanical energy. Okay, it will either try to increase it or will try to decrease it. 99% of the cases that we come across in our understanding of physics here, the non-conservative forces will try to decrease the overall mechanical energy of the system. It will try to convert the mechanical energy maybe in the form of sound, maybe in the form of heat or light. Okay. So it will try to dissipate the mechanical energy. That's basically your non-conservative force. Hence the example also. What you see that non-conservative force is basically a type of friction, air resistance, viscosity. These are basically the forces which try to decrease the mechanical energy of the system. And on the other hand, when you look at the examples of conservative forces, spring force, gravitational force, electrostatic force, magnetic force, tension, normal, all these forces are your conservative force that do not try to change the overall mechanical energy of the system. Okay. Another important and sometimes useful is this point, that work done in a round trip, if a body is being brought back to the same point, then the work done by the conservative force will always be 0. On the other hand, by the non-conservative force, it will be non-zero. Okay. Also, coming to the point, very important is that whenever we calculate the work done by conservative force, only that work is capable of changing the potential energy, or rather I should say that only these forces are responsible for writing this equation. You can write the change in potential energy only with respect to the work done by conservative force. Very simple words, I would want to put it this way. The change in potential energy will only be carried out by a conservative force. Non-conservative force will never try to attack the potential energy of the system. It will always try to attack the kinetic energy of the system. Okay. So, whenever we write this, the work done by a conservative force is equal to the negative of the change in potential energy. Always remember this. And how do you write the work done by a force? It is F into dx, or rather delta x, which is equal to negative of delta u. So that is why when I write F, it is basically minus of delta u by delta x. In a differential form, you can write it as minus du by dx as well. Okay, guys, that's where the equation gets related. Hope it is clear to all of you. Okay. Next one. Hi Suri Sir, can you explain work energy theorem? This is asked by Saeed Liaqad Ali from Kargil, Ladakh. Oh my god. somebody from Pakistan. That's nice. So Vedantu channel is getting popular in the neighboring countries as well. Okay, Saeed, welcome. Next question is similar to this. This is asked by Vaibhav Tiwari from Bareilly, UP. So he asked that how to apply work energy theorem in typical spring block problems and the questions involving circular motion concept. So you can read here that both the questions will get answered in few more coming questions, but still I will mention what exactly work energy theorem is. And please listen to this very carefully. Hello everyone, Rupali, Aman, Soham, everybody, welcome, and please teach with a smile. Okay, don't worry, I'm not being. I'm enjoying this session. Okay, I'm sure you guys are. So my bad, my bad. I'm so embarrassed. I'm so embarrassed. My geography. I'm so sorry, guys. Yes, Kargil is a part of India. Really embarrassed. Thank you so much for correcting me, guys. Okay. I think I thought of it as Lahore. Anyway, will not try to. Yes, yes, yes. Understood. So sorry. And really embarrassed. Okay. Thank you so much for correcting. Okay. So, guys, anyway, coming to the point, work energy theorem, I want to explain something very important for all of you. Thank you. Thank you so much for being so considerate, everyone. Thorough. Okay. Now, guys, anyway, let's come back to the understanding of work energy theorem. I want to give a very important, maybe I got overwhelmed because of the point that I want to mention here. Listen, everyone. Work energy theorem is nothing but law of conservation of energy. I hope all of you are aware about law of conservation of energy. It says that energy can neither be created nor be destroyed, but it can only be transferred from one form of energy to another form of energy. Right? So in any process, whenever the work is happening, energy will always get converted from one form to another. Okay? So what do I call work energy theorem as? So when we say that energy is getting transferred, say from mechanical to thermal, thermal to light, thermal to say electrical, any form of energy, whenever it is getting converted from one form to another, the process by which it gets converted from one form to another is nothing else but work. Work is the process by which energy gets converted from one form to another. So 99% of the question which you think can be solved from work energy theorem can also be solved by just applying law of conservation of energy. Now what exactly is the application of law of conservation of energy? Energy can neither be created nor be destroyed. That means what? Say a body is being taken from point A to point B. Just you have to equate the energy of the system at A and the energy of the system at point B. And I will show you that by solving few questions today with the help of just law of conservation of energy and by applying the work energy theorem as well. Okay, cool guys. So now see. So question, following the previous ones only, this is where the questions will come. In which type of questions we use work energy theorem, I have already given the idea that wherever you have to find out the value of potential energy, kinetic energy or velocity of the body, that is where work energy theorem will come into picture. Secondly, where the idea of force has not been given much and maybe a variable force is working over there. So that is where you don't want to use the work energy theorem. If you want, unless you are required to find the value of acceleration, don't go for force equation, go for the work energy theorem. Now comes a problem here, which is being asked by Burger, I guess. Burgar from Odisha. Oh, that's the name of the place. Sanjeev is asking this question. He says that an elastic spring of unstretched length L and force constant K is stretched by small length X. It is further stretched by another small length Y. Work done during the second stretching is how much? Okay. Okay, smart Sanjeev has asked this question. Okay, understood. So Sanjeev has asked that there is already a spring which has been pulled to a certain distance, say x. Okay, so certainly it will be storing some potential energy, say u initial. Okay, after that what do, you elongate it further so that the elongation which was already there, it gets further more elongated by a distance y, so that the new potential energy which is getting stored there becomes uf. Okay, so now what guys, in this process certainly there must have been a force F which must have been applied on it. So question wants us to find out that what is the additional work which was done from state A to state B. So you should know that the work which is done, usually in such questions they will always want you to find out the work done by the external force. So always remember, work done by an external force is nothing but the change in potential energy. Work done by external force is equal to the change in potential energy. Means what? If I am that agent who is pulling the spring, I am going to lose my energy, and that energy will get stored in the form of potential energy of the system of the spring, following the rule of law of conservation of energy, that energy can neither be created nor be destroyed, it can only be transformed. So nowhere the energy got created, I was already the source of energy, I pulled the spring, I lost the energy, energy was gained by the spring. Okay, in this process the law of conservation of energy worked. Okay, now guys, this is going to be very simple. U final minus U initial is basically what is to be found. Not doing the final calculation, Sanjeev, I'm just giving the idea. So U final is basically what? U final is half k, the elongation, which is x plus y the square, and initially the energy was half k x square. So you just simplify this overall expression, you will get the answer. Okay, the final energy, because the total elongation is x plus y, earlier it was x. Okay, no, it will not be minus. People are asking, sir, why you are not writing minus here? Work done by external force should be equal to minus delta U. So remember, again and again repeating, work done by conservative force is equal to the negative of the change in potential energy, but work done by external force is equal to the change in internal energy. So you can say that the conservative force is the work which is done by the spring force. I'm not calculating the work which is done by the spring force. Whenever the question says work done that you have to find out during such situation, the question is inherently asking you to calculate the work done by the external agent. Unless question specifically asks you find out the work done by the spring force, question wants you to find out the work done by the external agent. Please remember this part, guys. This will be applicable in electrostatics, this will be applicable in gravitation, this is applicable in the system wherever work or energy is involved. Please remember, work done by conservative force is equal to the negative change in potential energy, but work done by the external force is equal to the change in potential energy. Or in short, external agent work and the conservative force work, they are just opposite of nature. Okay. Now, next question says, because slide before the previous one had a question to explain this with respect to spring, with respect to circular motion also. So here Shiva Sanjay has asked this question. He's from Visakhapatnam. He's asking, sir, please explain the concept of vertical circular motion. No matter how many times I study it, I'm failing to visualize and deal with it. Fine. So I'll just try to give you a overall idea here. There is a body which is moving in a vertical circular motion. Say its radius is small r, and this body is being made to move in a vertical circle. We want to find out by giving it the name as point A, point B, point C, and point D, the minimum velocity required at point A and C to complete the circular motion. Okay, so in this question we'll try to apply law of conservation of energy. I'm considering this point to be h equal to 0. So guys, if this is h equal to 0, then the height of this point C is nothing that you can see, it is equal to 2r. Okay, so now pay attention. How do I use the law of conservation of energy to find out the value of velocity at A and velocity at C? First of all, When I write the equation at C, first of all, I will write the equation of force over there because the body is moving in a circular path. Both tension is acting downward and mg is acting downward. Tension because it is a string which is attached to a stone and maybe moved in a circular path. So the total downward force which is acting towards the circle center is mg and tension. So I will write T plus mg equal to mvc square by r. But because we are speaking about the minimum velocity case, mg cannot be 0, so I am making tension as 0. Remember, because we are talking about the minimum velocity case. So from here, what you see, mg is equal to mvc square by r. M gets cancelled. The value of vc, as you can see, comes out to be under root of rg. I am sure you remember this value also, the expression. So the minimum velocity here comes out to be root rg. Please remember this, a very important value. And now to find out the value of VA, I will use the law of conservation of energy by saying that energy at A is equal to energy at C. Okay. Now energy at A is purely kinetic. It is half mVA square and no potential energy because it is H equal to 0. But energy at C is half mVC square plus m into G into H, and H is equal to 2R. Now guys, pay attention. I'm applying work energy theorem only. But as I said, work energy theorem is nothing but law of conservation of energy only. So what you write as mg into 2r is basically the work done by gravity. And if you take this term here, it will be change in kinetic energy. That is what work energy theorem is. Work energy theorem says that the work done by a force is equal to the change in kinetic energy. So if I take this mvc square to the left side, I'm basically talking about the change in kinetic energy here. Okay. I can read the charts, Nitish. Okay, I'm explaining the concept. Please pay attention. So now, I am basically applying work energy theorem, which is nothing but law of conservation of energy. When I write this, this is what I say is application of law of conservation of energy. So I'm simplifying now. M got cancelled simply, and I'm multiplying equation by 2. I have VA square equal to VC square plus 4GR. Okay, I hope it is visible. Okay. Yeah, so we already know the value of VC square here. So VA square is equal to VC square, as you can see it here, is under root RG. Square of that will be RG plus 4RG. So that simply means it is 5RG. So the value of VA comes out to be under root of 5RG. I'm sure you are aware about these values already. So the value of VA comes out to be under root of 5RG. If possible, please remember these expressions. The minimum velocity is at A and C to complete the circular motion. Okay. Okay. Thank you, Yaragula. Next one. Please explain with an example of collision mixed with work energy theorem, and also help in approaching questions of collision questions. Okay. So the question was asked based upon the similar thing. This first question was asked by Kunal Sharma from Badmer. Okay. And the second question is asked by Amrit Raj Sinha from Lucknow. So Amrit ne jo question पूछा है, that is mostly what Kunal has actually asked for. So question is that a bob of mass m suspended by a string of length L1 is given a minimum velocity required to complete a full circle of the vertical plane, which means what? Under root 5rg velocity has been given. So at the highest point, it collides elastically with another bob of mass m, which is suspended by a string of length L2, which is initially at rest. So both the strings are massless and inextensible. If the second bob after the collision acquires the minimum speed required to complete the vertical circle, that means it also acquires it under root 5rg for that, then we have to find out the ratio of L1 by L2. Okay. So this is very good question, Amrit. Yes, Mugambo khush hua ye question padhne ke baad mein. So what he is asking, that say there is this object which is hanging like this, and there is another object which is hanging like this. Okay, this is the hanging points. So what happens? This is L1, this is L2, and this object is being given some velocity in this direction, say under root 5 r, or r for this is L1 into g. Under root 5 L1 g is being given to it. It moves like this and hits this body of same mass. Whenever two bodies of same mass collide with each other, their velocities interchange. I hope you guys are aware about that. Their velocities just get interchanged. So whatever is the velocity of it when it reaches here, so the velocity of it when it reaches here is how much, guys? When it reaches it here, it becomes under root of L1g, right? Under root of rg at the topmost point. I hope you remember this. Under root of rg becomes its velocity, and it collides with the body which is here. So this body will get the velocity and will move in the vertical circle. So this body has to get its under root of 5 rg, which is 5 L2g. This is what happens. I hope the question is clear. Just have a look at this diagram also. Body A got this velocity in the beginning, moved up, it gained this, its velocity of under root 5 GL1 became under root of GL1 as it reached from A to say point B. There it collides with another mass which is same value. So obviously this mass is going to get the velocity which is under root of 5 GL2. And these two velocity, this one and this one, they are going to be same velocity. That means all you have to do in solving this question is under root of GL1 equal to under root of 5 GL2. So under root and g get cancelled. Basically L1 is equal to 5 L2, and the ratio L1 by L2, the ratio of L1 by L2 is nothing but 5. Okay? Yes. Perfect. Very nice. Very nice. Okay, Amrit is here in the session. Very good. Okay, Sandhya Sinha says that it's me, Amrit. Okay. Awesome, guys. Next question. Again, a very popular question being asked by Ragashri from Kadapa. And question says that a uniform cable of mass m and length L is placed on a horizontal surface such that 1 by nth part of it is hanging, maybe 1/3, half, that value may be given, may not be given, is hanging below the edge of the surface. To lift the hanging part of the cable up to surface, the work done should be how much? That work done is to be found. Okay, work done by external agent. That means if you are the one who has to lift it, you are the external agent, not by gravity. Okay, how to solve problems related to the chain hanging half of that part kept on the table in the most easy way? And I will tell you the most easy way, Lakshya from Vellore. Okay, so I'll tell you guys how to solve this question. बहुत ही simple तरीका होता है. Please pay attention to this. So this is your table on which a chain is hanging, is placed, and some part is hanging. So if the total length of the chain is L and its L by N part is hanging, 1 by nth part is hanging, so the remaining part is on the table. Don't worry about the table. The part which is placed on the table, don't even worry about it. Okay, guys? So if this is L by N part, can I say that considering the chain is uniformly dense, the mass is also 1 by nth part of the same mass? Think of it in this way. If half of the chain is on the table and half of the chain is hanging, can I say half of the mass is on the table and half of the mass is hanging? If 1/3 of the chain is hanging, then m by 3 mass is hanging and 2/3 of the mass is on the table. So similarly, if 1 by nth part of the chain is hanging, then L by N length is hanging and m by N mass is hanging. As simple as that. Okay, cool. Now guys, the only trick to understand this question is, please pay attention. I will change the color so that it's understandable for all of you. For the cursor, the center of mass of the portion which is hanging, only focus on the portion which is hanging. Okay, because your work will only lift the part which is hanging. The part which is already on the table, you are not changing its energy. No velocity given, so no kinetic energy. Its height will also not be changed. So basically the part which is on the table is useless. So guys, this is basically the center of mass of the hanging part. And how much is the location of this particular center of mass? This part is hanging at half of the distance. That means L by 2N is the height by which you need to lift it. I hope you guys are getting this. The overall length which is hanging is L by N, but the center of mass is at the half of that length. So this is basically the height by which you need to lift the mass, and how much mass? M by N. So guys, let's call this mass as M, this as H. So the work which you will do will basically increase the potential energy. Or how much will you increase the potential energy? mgh. Yes or no? So how much is the mass you are lifting? M by N. Okay, writing it here. It is M by N into G, and H is L by 2N. So the work that you are doing is basically mgl by 2n square. That's basically the work done. Okay, Ragashri. Now you can put the value of n as 1 by 2, 1 by 3. So 1 by n value you can put, and you can check also. Okay, guys. Hope it was clear. Next question from it's being asked by Atharva. He asked that how to solve the problems of water raised by a motor pump to a certain height, and that is why I have picked the question myself. The question is, a pump is required to lift water. Please read the question, guys. It says that a pump is required to lift 1000 kg of water per minute from a well 12 meter deep, and it ejects the same amount of water at a speed of 20 meter per second. How much work is done per minute in lifting the water? Okay, that per minute, that simply means power is being asked, and we also have to calculate the output power in horsepower. Okay, we know that 1 horsepower is 746 watt. Okay, cool. So now the total power is basically the total work done per unit time. And how do I calculate the work done per unit time here? So I will say it is basically mgh per unit time plus half mv square per unit time. Basically, external agent is working. External agent is the pump. It is making the water increase its potential energy. Also, it is giving it the velocity, that means kinetic energy. So guys, the mass of water lifted is 1000. G value I am taking as 10. Height is 12. And this is happening per minute. So this is 1 minute. Plus half into 1000 kg of water. Velocity is 20. Square that value, it is 400 by 1 minute again. Okay. That means what, guys? This comes out to be 12 into 10 to the power 4 plus this becomes 200. So this is 20 into 10 to the power 4, right? 20 into 10 to the power 4, perfect. So this is 32 into 10 to the power 4 joules per minute is basically what we have got. Okay, so if you want to convert it into joules per second or watt, this will be 32 by 60 into 10 to the power 4 watt. Okay, Atharva, I hope you are getting. So we got the value of power in watt. But now if you want to convert the value and find the power output in horsepower, then you can convert this value of power, let's call it P dash, value only. So this will be P by 746 watt. Means you will convert the watt into horsepower by dividing the value of watt into horsepower by dividing it 746. So all you have to do is 32 by 60 into 746 into 10 to the power 4. This will be horsepower. Okay, I can see that it's not visible. So I'll just write it here. Okay, Atharva, I'm writing it here. Power will be 32 by 60 into 746 into 10 to the power 4 horsepower. This is basically the same power calculated in the value of horsepower instead of writing it in watt. Okay. Yes, Ishika, I've written it there only. I've written it on the top so that it's visible to everyone. Okay. I've written it on the top so that all of you can see. This is basically what we are doing, converting it into horsepower. Okay. Yeah, we can calculate it already in the value of seconds. Yes, Sai Sarvani, we can. Okay. Next one. This is asked by Anushka Paul from Kolkata. She says that a spring is kept compressed by pressing its end together lightly. So spring is being compressed lightly and then it is placed in the strong acid and released. So what happens to the energy that is stored, which was stored as the potential energy of the spring? So I have given an answer to this very simply. The question is, so the answer says that when the spring dissolves in acid, the potential energy of the spring which was stored there will be passed to acid and the internal energy of the acid will increase, hence its temperature will increase. So basically the spring potential energy is converting into heat energy. Law of conservation of energy is still applicable. Okay, Anushka. Next one. Shankha, hi Shankha. You asked that, sir, can you explain? Dot. We always use the change in mechanical energy, kinetic and potential, but energy is always dissipated in many other forms. So where is the practical need to use this concept? So first of all, when we are studying physics in 11th and 12th standard, we are not studying the entire realistic physics. We are studying a lot of things which are idealistic. For example, when we studied work, energy, and power, in fact, before that, when we studied kinematics, motion under gravity, we assume that there is no atmosphere. Things are falling in vacuum, which is not the realistic case on Earth at least. Okay, maybe at some level it is realistic in space. So given the benefit of doubt, but when we study Newton's laws of motion, we assume that friction is absent. Before we study friction, all the questions that you solve, you consider that the surfaces are smooth, string is massless, frictionless, pulley is massless, frictionless, ideal situations are given. So those things we study so that we can understand what idealistic situation is. So similarly, when we are speaking about kinetic and potential energy variations, whenever we throw an object, say upward, Shankha, I hope you're here and listening. When I throw an object upward, say with a speed u from point A, it will rise up and up and up and up and up and finally say at B it will stop after traveling for a height say h. So we say that energy at A should be equal to energy at B, right? So that's why we say that energy at A is half mu square and energy at B is mgh. They are equal. But practically, you know that there is some air resistance which will also be there and it will actually dissipate the kinetic energy of the body. And the body will actually not go to height h, it will go to a height little less than h. But then also energy by the time it will reach to B will be mgh plus some heat which will be getting produced because of the friction. But overall, what I'm trying to tell you that yes, energy will get dissipated in the realistic scenario. What we are studying here is mostly to understand the concept of law of conservation of energy. Maybe when you will be studying your engineering, whichever engineering that you will be getting into, that is where the realistic scenario will be taken into account, that air resistance is present, friction is present. So that is why the kinetic energy which was given to the body at t equal to 0 at A will not be equal to just mgh, will also be resulting in some amount of heat generation. Okay, awesome. Next one. Sir, many times I'm stuck with the doubt that how to know the sign of potential energy in gravitation. We take negative and in some cases positive. Why? Noel Yanam from Pondicherry. Noel, I would say the best question of the day. This is as far as the conceptual question is concerned. Because I remember when I was a student back then in 11th and 12th standard, I studied it in 11th standard that potential energy, gravitational potential energy formula is minus g m1 m2 by r. But when we went to electrostatics, the same concept, the potential energy became k q1 q2 by r. Guys, pay attention. The potential energy, the different formula that you know. You know the formula is mgh for gravitation potential energy. You know it as minus g m1 m2 by r, and you also know it as k q1 q2 by r. So where to use positive sign, where to use negative sign, I will just clarify this thing forever. Please, I'm not getting into the explanation that how negative and how positive comes here. Rather, how can you remember when to write positive, when to write negative. So first of all, this thing. This is only applicable when the height of the body is very small in comparison to r, radius of the earth. So this formula, by the way, is only applicable for chapters that you study in kinematics. Okay, only till the time you are studying kinematics and chapter of work energy power, then only you can use it. Only for the part that you are studying kinematics till work energy power, the formula mgh is working. But the moment you are in the chapter gravitation itself, that is when the real form of potential energy comes into existence, because this formula is nothing but change in potential energy. So change in potential energy you can use at mgh, but when you are using the gravitational potential energy, guys, the formula is written as minus g m1 m2 by r, and when you are studying it in electrostatics, it is k q1 q2 by r. Now the point that I want to make very clear for everyone to understand, guys, pay attention to this. Let me just erase this so that we can understand this part very easily. If the force is attractive, if the force acting between the two objects which are storing the potential energy is attractive, then potential energy is negative. The negative formula or the negative value of potential energy will mean, negative potential energy will mean the force between two objects is attractive. Okay, but if force is repulsive, which will never be the case with gravitation, if the force is repulsive, the potential energy is positive. Always remember that. Okay, that is why in gravitation, यहाँ पे example देता हूँ, in gravitation the potential energy will always be minus g m1 m2 by r, and similarly in electrostatics also, guys, in electrostatics also it will be k q minus q by r. You guys know that in electrostatics also the attractive force only comes into existence when one charge is positive, other charge is negative. So you can put the value of charge as positive and negative, you will see that the value of potential energy will come out to be negative. Yes or no? The general formula is written as k q1 q2 by r, but when you are writing it in electrostatics, if you start putting q1 as positive, q2 as negative, the formula becomes, the value becomes negative, and that means positive and negative charge are attracting each other. But when you are writing for this part, guys, this will not be applicable for gravitation because no repulsive force is there. So when you write the potential energy, it will be k, either you will write it as plus q1 plus q2 by r because repulsive force will happen between like charges, or let me give you the better example, that is by writing it as minus q1 minus q2 by r. You can see that whenever I write this, the overall value will always be k q1 q2 by r, which is positive term, because both the charges are negative, they multiply to give you the value as positive. Okay, understood? Mohsin, stay tuned, I will tell you how can you ask the doubts. Mohsin, please stay tuned, stay in the class. By the end of the session, I will tell you how can you ask the doubts. Okay, clear everyone? Point got clear? When the potential energy, and in whichever chapter you have to take it positive or negative, just think about the force acting between two objects. Is it repulsive? Is it attractive? If the force acting between two objects is attractive, potential energy term you have to write as negative. Okay, then you just write the magnitude of things. But if you are writing about repulsive forces, which are possible only when you are dealing with like charges, then the term will be positive always. Okay. Now this one is being asked by Aditya Kotra from Gurgaon. He says that explain the question in which half of the slope planned is having friction and other half is frictionless, and we need to find the velocity of it when the body reaches ground. So because no fixed question was asked, so I'll give you the idea here. And by the way, this is where I will tell you how work energy theorem can be applied. So guys, first of all, say I will divide it into three parts, A, B and C, the overall length of the inclined plane. Say the angle of inclination is theta, and this length is L by 2 and this length is L by 2. Okay, So when the body is in this path A and B, you can see it is frictionless. The force which is responsible to bring it down, I'm not getting into the resolution of the force, I'm sure you are aware about it. The force which brings the body down is basically mg sine theta when the body is moving from A to B. So work done in A to B will result in the change in its kinetic energy, right? So what is the work done from A to B? You can see that the body is moving along AB and the displacement is also happening along AB. The displacement is L by 2, so the angle is 0 degree. So force, which is written as mg sine theta, not writing entire force. I'm just writing the component of the force which is doing the work. So mg sine theta and the displacement L by 2, not writing sine cos 0 degree because the angle between these two is 0 degree. Understood? And this should be equal to the change in kinetic energy. So final kinetic energy will be half mvb square, the velocity here, and initial kinetic energy was 0, right guys? So from here we are getting the value of half mvb square. Between B to C, now guys pay attention to this part, very important this is, because this is where friction is present. Okay, so in the part where friction is present, guys, when the body is going to be here, obviously mg sine theta is still acting, it is the force responsible for bringing the body down, but it also is experiencing a force of friction, and force of friction is say mu mg cos theta, which is mu into n. You know that normal force is being balanced by mg cos theta. Okay, so that is why mu into n is mu mg cos theta. So now the forward force is mg sine theta, backward force is mu mg cos theta. So the work done will be mg sine theta minus mu mg cos theta. This is the force, and the total displacement traveled from B to C is L by 2, and this should be equal to the change in kinetic energy, which is half, okay, not visible, so I'm writing it here. This should be equal to half mvc square minus half mvb square. You already know the value of half mvb square from here. You can put that value here and you can calculate the value of vc square, provided the values of mu and theta are given to you. I've given you the two equations, guys. All you have to do is put this value. Eventually what you will be left with is mu mg cos theta into L by 2, because half mvb square is going to get added. In fact, no, it will be added here, not cancelled. Okay. Swati, I have applied the work energy theorem here. Some people having doubts are what happened to the change in potential energy. So that is what I told you in the beginning. I'm applying the work energy theorem. Work energy theorem says that the work done is equal to the change in kinetic energy. This is basically the work energy theorem is. This work itself is basically the potential energy change, because the work which is done by conservative force will change the potential energy. Here, because non-conservative force of friction is also applicable, that's why I have to work with work energy theorem. Okay. Next one, asked by Ritesh from Bangalore. Sir, what is the difference between average power and instantaneous power, and also formula for the same? So guys, in fact Ritesh, it's the same thing or same difference which is there between instantaneous velocity and average velocity. When you talk about instantaneous velocity, it's the small amount of displacement per unit time, and average velocity is total displacement upon total time. Similarly, you can see the formula. Average power is the total work done upon total time taken. Okay, and instantaneous power is small amount of work done for a very small instant of time, and that is basically your force and velocities dot product. Okay, I hope it is clear. Next one, a particle of mass 0.01 kg travels with velocity which is given by this vector. After some time, its velocity becomes 8 I cap plus 20 j cap. The work done on particle during this interval of time is going to be how much? This is a question that is asked by Deepshika. So Deepshika, I'll give you the idea about the question itself. See, you can see that velocity is given, mass is given. So simply work is equal to the change in kinetic energy is what I'm going to apply. So work done is basically half m v final square minus v initial square is what you will be applying here. So if I want to calculate v initial, it is under root of 4 square plus 16 square, which is 16 plus 256 in under root. I'm sure you'll be able to solve this, guys. And v final will be under root of 8 square plus 20 square, which is 64 plus 400 in under root. Okay, so this is 464. ये simple लग रहा है, so that's why I'm able to write it. Okay, this is 272 in under root. So what you see here, guys, okay, what you see here now, this is half, mass of the object is 0.01, so that is 1 upon 100. V final square is 464 minus 272. So when you simplify this, Deepshika, the answer will come out to be 0.96 joules. This will come out to be the answer. All we did by using the vectors is by finding the value of the velocity. Okay, everyone? Fine. So many people are asking that, sir, how can I ask the doubt? How do I ask the doubt? So for everyone, guys, you can ask your doubts by going on Vedantu JEE channel. Subscribe to it first of all. When you are done with the subscription, go to the community page. On community page, you will see that every day the information is posted. Okay, when we post that information, the doubts and the Google form link is being shared over there. All you have to do is click on that link. It will be taking you to a page, a Google page, where you will be typing your doubts along with your name. That's why I'm able to know the name of the people, because they have given me the information. Okay. Understood, everyone? You can go on Telegram group as well. All those informations are available on the description of this video. Okay, guys. So this involves all the doubts which I had collected from the students. Maybe your name was not there, students, but as I told you people, that majority of the doubts that I have taken were the common doubts which were asked. Okay, don't feel bad if your doubt was not included exactly with your name. It's not about your name. I have completed all the topics which were asked as far as the doubts are concerned. Okay, so guys, if you want to continue your JEE preparation because the JEE examination had got postponed, you can come for our crash course where we are giving 90 live classes every week. Every day you are having 3 sessions. 20 comprehensive test series is going on. Doubt solving sessions, you can watch replays and recordings as well. The batch has already begun, guys. How can you become a part of it? All you have to do is follow this link which is available in the description of this video. Don't forget to use the coupon code SMCC and the crash course will be yours for just rupees under 6,000. Okay, I hope steps are clear. This is the link. Click on enroll now. Use that coupon code that I'm telling you, SMCC, and then it's all yours. Okay. Cool, guys. I hope that you guys enjoyed the session today, work, energy and power. I took this chapter, the doubts from it, because one of the very fundamental chapter this is. Okay, so if you guys enjoyed this video and the doubt solving with me, then you can see that like button over there. Click on that. Okay, do share it with your friends, tell them as well. And if you have not done it yet, if you want to ask your doubt, I'm telling you again and again, just subscribe to this channel. Okay, come to the community page every day. You will get to know which subject doubt is happening next day. Cool, guys. So even during this lockdown, the learning won't stop and it should not stop. Cool, guys. So I'll see you all again with another topic. I'll float it on the community page. Be with us, subscribe to the channel, and you will get to know which next chapter doubts I'm going to take. Okay, till then, keep studying, keep smiling, and don't forget, you have to stay safe. Don't go out. Chalo. Bye bye, guys. Take care.